So here we go. So yesterday, what we did was what we called left and right and midpoint Riemann sums. So basically, it took turns. We had some rectangles where the left side of the rectangle was on the curve. You had some where the right side, give it a minute, and then you had some where the middle of the rectangle. And we found out yesterday that the more rectangles you have, the more accurate the area is. It makes sense. Because if I could split that up on your paper into infinitely many rectangles, it's going to be a very good estimate of the actual area under that curve. Okay, so now what we're going to do are trapezoidal Riemann sums. So instead of drawing rectangles, we're going to draw trapezoids. All right. So it gives you the formula up here in case we've forgotten, which I'm sure we have, of the area of a trapezoid. It's 1/2 times the height of the trapezoid, which is the non-parallel side. And then times the two bases, which are the parallel sides, added together. And it says that in here. All right. So on this interval from 1 to 7, we're going to split up the area into trapezoids that have a height, or I like to call it width, it makes more sense, of 2 units. So from 1 to 3, that's my height of the trapezoid. And so it goes up to here, and then a trapezoid looks like that. We're going to do 7 of those. So the next one goes from here to here. Have that line. That looks like that. Here. So we're going to find the area of each one of those shapes and then add them all up together. So we know that the area of any trapezoid is 1/2 height times the two bases added together. So the height for all of these is how far apart they are. And they've all been, it's at a height of 2. It is a width of 2. It's the one side, it's the non-parallel side. So it's 1/2 times 2. And then the bases, like for this black trapezoid, it's the parallel sides. So it's how tall this is, which you find by using this point. Well, that point is f of 1. Because this equation is f of x, which was written out on the other pages. And so the height of this next line would be f of what? 3, because remember they're 2 apart. This next one is at 3. See it? Okay.
Isn't it 8?
It does end up being 8 for that one. Okay, then notice what's going to happen. The next one is going to have the exact same 1/2 times 2, right? And then inside here, we're going to have this line, which is f of what? 3. So it's f of 3 again, right? And then it's going to be f of 5. And then for the next one, f of 5 is going to be used again. So instead of writing it all out that way, what we can do is to estimate the definite interval from 1 to 7 of f of x. That just means we're estimating the area under that curve, which is f of x, from 1 to 7. It's going to be (1/2) times 2. And then we have f of 1 plus 2 f of 3s plus 2 f of 5s plus only 1 f of 7. Calculator is going to be helpful here, by the way. Yeah, you think? Now, do you see why there's only 1 f of 1 and 1 f of 7? Because it's at the beginning and at the end. That one's not a part of 2 trapezoids. Okay, good. So f of x was given earlier. I don't know where it is now. Here it is. F of x equals -1/3 x squared plus 2x plus 5. That is that parabola. And we actually already found all of these earlier. We found them on the last problem. So 1/2 times 2 is, of course, 1, so that's not going to make a difference of anything. I'll write these out the first time. -1/3 times 1 squared plus 2 times 1 plus 5. I got 6.66667. I'm putting more than 3 because my final answer needs to be 3. Everybody cool with that? All right. Then we plug in 2. So if you cursor up, by the way, and hit enter, it'll bring that equation you just typed in down. And then you can just change those 1s to 2s, or 3s, sorry. That's 8, like you said. But we're multiplying it by 2, so it's 16. F of 5. That's the 6.66 whatever, but it's times 2 again. So it's 13.33333 whatever. And then f of 7. Which is 2.666667 whatever. If I add all that up, I should get about 38.667. All right, so the next one is trapezoidal Riemann sums with the intervals of length unit 1. I'm not going to type all these in individually. I'm just going to give you practice at drawing the pictures. We're going to write out what it should look like, and then you're just going to give the answer. So this time, it just has a height of 1. So that means it's just going from 1 to 2. It's that trapezoid. And we're going to keep doing it all the way across. Bless you. So you see how it's getting really close to being what it actually is. You know, there's a little bit of space here